Hi everyone. Today I'm going to show you how to work with SQLite databases using Python. SQLite is a super simple, lightweight database that doesn't need a server to run. It's perfect for small projects, local data management, or quick prototypes. So, why use SQLite? The answer is, SQLite is easy to use and integrates seamlessly into your applications. It's great when you need to store and manage structured data without the overhead of a full-fledged database system. In this video, I'll guide you through connecting to an SQLite database from Python and performing basic CRUD operations. CRUD stands for Create, Read, Update, and Delete, the four basic functions you need to interact with a database. Let's get started! By the end of this tutorial, you'll know how to connect to an SQLite database, that is, learn how to open and create databases directly from Python and create tables to define structures to store your data. Insert data, meaning add new records to your database, and update data, that is, modify existing records and remove records from your database. So grab your Python environment and let's dive into the world of SQLite and Python. Let's make data management easy and fun. All right, now we're diving into a crucial step that is setting up your development environment. Whether you're a beginner or a seasoned pro, having a dedicated virtual environment can save you a lot of headaches down the line. So, let's get started. First things first, let's navigate to our project directory. You can do this by opening your terminal and using the cd command to change to the directory where you want your project to live. Type this command in your terminal cd, path, \to your, again, \, and project directory. Great. Now that we're in the right directory, we need to create a virtual environment. A virtual environment is an isolated environment that allows you to manage dependencies for your project separately from your global Python installation. This is super useful because it helps avoid version conflicts and keeps your project dependencies organized. We'll be using Python's built-in venv module to create our virtual environment. It's simple and effective. Just type the following command in your terminal: Python 3 -mvenv and var1. Here, Python 3 specifies the version of Python you want to use. -mvenv tells Python to use the venv module, and var1 is the name of your virtual environment. You can name it anything you like, but var1 is a common choice. Awesome. Now that we've created our virtual environment, we need to activate it. Activating the virtual environment ensures that all the packages we install will be specific to this environment and won't affect other projects or the global Python installation. To activate the virtual environment, use the following command: source vir1 \bin and activate. You should see your terminal prompt change to indicate that the virtual environment is active. Now, any Python commands you run will use the Python interpreter and packages from this virtual environment. And there you have it. You've successfully set up and activated a virtual environment. From here, you can start installing packages with pip and know that they're safely contained within your project. We'll be using Faker to generate synthetic records. So first, install Faker using pip. Follow this command to install Faker using pip. Pip install Faker. And there you go. Installation completed. Now we need SQLite 3. But the SQLite 3 module is included in the Python standard library, so no installation is necessary. Once you have Faker installed and are using a recent version of Python, you're all set. All right, time for some Python script. Let's jump into our project directory and create a Python script. Open your favorite code editor and create a new file named database-connection.py. In this file, we're going to write our Python code to connect to an SQLite database. Here's the code to connect to our database. First, we should import SQLite 3, so importing the SQLite 3 module. This module provides the necessary functions to interact with an SQLite database, and now we have to connect to the database. So, to connect to the database, we are using the connect function. This connect function attempts to connect to a database file named example.db. Here, if the database already exists, then it connects to it. If database doesn't exist, SQLite will create it in the current working directory. In my directory, the database already exists, so it connects to it. It's as simple as that. With just a couple of lines of code, we've connected to our SQLite database. Let's run our script to see it in action. After running the script, you should see that example.db has been created in your project directory. If the file already existed, the script would simply connect to it. Now that we've connected to our database, we're ready to start interacting with it, creating tables, inserting data, querying, and much more. Let's jump into the action. I hope you found this tutorial helpful. If you did, give it a thumbs up, subscribe to our channel, and hit the bell icon to get notified about our next video, where we'll dive deeper into SQLite operations. Drop any questions or comments down below. I'd love to hear from you. We'll create a database cursor to facilitate running queries. The cursor object provides methods for executing queries and retrieving their results, functioning much like a file handler. Using the connection as a context manager within a with statement can be particularly advantageous. Here's a little piece of code to connect to a database. Check it out. Let's break it down. The with SQLite 3.connect, example DB, as con. This line is like picking up the phone and saying, "Hey, database, let's chat." The example DB part is the name of our database file. Now, once we're connected, we need something to help us send and receive messages. That's where the cursor comes in. A cursor in a database is like a remote control. It helps us send commands to the database and get the results back. Inside our with block, we create the cursor and start running our queries. Let's create the cursor. Cursor equal to, and the DB alias name we given as con and dot cursor. This way, you don't need to worry about closing the connection yourself. The connection is automatically closed when the code inside the with block finishes running. However, in this tutorial, we'll still manually close the cursor objects. All right. We are done with the cursor creation. Now it's time to create a table to store some information. Let's start. We're going to create a table called customers in our database. Let's break it down together. First things first, we need to import the SQLite 3 library. We already have it and connected to a database. Next, we created a cursor object, and let's create a table named customers. Now comes the exciting part. We use the cursor to execute an SQL command that creates a table called customers. Cursor dot, execute, open parenthesis. Create, table and table name. That is customers, again, open parenthesis. ID, it is an integer with primary key. Next, first name, we are storing alphabets, so it's a text and not null. Last name, same as above type. Email, it is also text but unique and not null. Phone as text num orders. This is an integer. Close parenthesis, and after defining our table, we use con.commit to save our changes to the database. Then, we print a success message to let us know everything went smoothly. Finally, we close the cursor since we're done with it. We will run the script and see the output. There you have it. Customers table created successfully. And there you have it. In just a few lines of code, we've connected to a database, created a table, and made sure everything was saved properly. If you found this explanation helpful, be sure to hit that like button and subscribe for more coding tutorials. Got any questions or topics you want us to cover next? Drop a comment below. We are going to perform some basic CRUD operations on a database table. In this example, we will focus on inserting records into a customer's table using a script. To generate realistic data, we'll use a library called Faker, and we already installed this Faker library. Although the example inserts 10 records, you can adjust this to insert as many records as you like. We'll use Faker to create fake data for each record. We'll insert these records into the customer's table using a parameterized query to avoid hard-coding values. All right, let's have to look at the code to insert records. SQLite 3. This library allows us to connect and interact with an SQLite database, random, used to generate random numbers for the num orders field. Faker, a library to generate fake data, and fake equal to Faker. This line creates a Faker instance to generate synthetic data, and this is database connection. We already know it. Now comes the actual code. Inserting records. Num records equal to 10. This line specifies the number of records to insert. A loop runs 10 times to generate and insert fake data for each record, first name, last name, email, phone, generated using Faker and NUM orders, a random number between 0 and 100. Cursor.execute insert into customers. This code inserts the generated data into the table using a parameterized query. And finally, we commit the changes and closes the database connection. Finally, we run the script to see the output. It will insert 10 records into the customer's table and print a success message. There you go. That's it. We've successfully inserted synthetic records into the customer's table using a clear and simple script. After inserting records into the customer's table, we'll read all the records and then update the num orders field for the customer with ID but 1. We will use SQL queries to perform these operations. Here, cursor.execute and select from customers. This line executes a SQL query to select all records from the customer's table, and all customers equal to cursor.fetch all. This code retrieves all the results of the query and stores them in all customers. And for customer in all customers, print customer. This loops through each customer record and prints it. Now comes to updating the records in the customer's table. Here, customer ID index1 specifies the ID of the customer we want to update. New num orders, all.customers. +1 retrieves the current num orders for the customer with ID 1, the first customer in the list, and increments it by 1. And finally, this line of code, cursor.execute. It executes an update query to set the new value of num orders for the customer with ID 1. When you run this script, it will. First, it will connect to the database and read and print all customer records, commit the changes that is updating the records, and close the database connection. If you found this tutorial helpful, don't forget to give it a thumbs up and subscribe for more programming tips and tutorials. All right. Now we will show you how to delete a customer record from a database using a simple Python script. We'll guide you through each step, making it easy to follow along. We are going to delete a customer from our customers table in the database. Let's get started. Here's the code you'll need, and we'll explain each part in detail. Here, we specify the ID of the customer we want to delete. In this case, it's 3. We connect to the SQLite database named example.db. Using with ensures that the connection is properly closed after the block of code is executed. We create a cursor object to execute SQL commands. We use the delete statement to remove the customer with the specified ID. The question mark is a placeholder that gets replaced by the value of CID to delete. We commit the changes to ensure the deletion is saved in the database. We print a message confirming that the customer with the specified ID has been deleted. Let's run this code and see the result. And that's it. You've successfully deleted a customer record from your database. This script is simple and straightforward, making it easy to perform database operations using Python. And that's a wrap on our tutorial for working with SQLite databases in Python. We've covered how to insert, read, update, and delete records in a SQLite database using simple Python scripts. These basic CRUD operations are essential for managing data in any database application. By now, you should feel confident in your ability to handle these tasks in your own projects. Remember, practicing these skills will make you even more proficient, so don't hesitate to experiment and explore further. If you enjoyed this video and found it helpful, please give it a thumbs up and consider subscribing to our channel for more tutorials on Python and database management. Don't forget to hit the notification bell so you won't miss any of our future content. We'd love to hear your thoughts and any questions you might have in the comments section below. Your feedback helps us improve and create content that's most useful to you. Thanks for watching, and happy coding!